Okay, so number 1 said to find the equation of a parabola that has the vertex -3, 6 and passes through 1, -5. So this is my h, this is my k, this is my x, this is my y. And the standard form is y equals a times x minus h squared plus k. So then I plug them in. The y is -5. The a is what I don't know yet. The x is 1. The h is -3. So minus the -3 becomes +3 squared. Plus k, which is 6. Again, quiz-wise, you guys forgot the squared on some of it. So please be careful. Don't do that again. Learn from mistakes. Don't repeat them. So this becomes -5 equals a times 4 squared plus 6. -5 equals a. 16 plus 6, subtract the 6. I get -11 equals a times 16, divide by 16 on both sides. And a is -11/16. So then when you plug it back in, you're plugging in just your a, your h, and your k. So y stays as y, the a is -11/6, x stays as x, minus a -3 becomes +3 squared plus 6. And there's your correct answer, which I think they shuffled around. But in this one would have been B. Okay, 2 questions on that one. Okay, 2 said find the function of given solution. So you got -4, 2 plus √3, and 2 minus √3. Remember, you're changing the signs on these, so this would be x plus 4, x minus 2 minus √3 because they both change signs, x minus 2 plus √3. And then also remember, I give you a shortcut for these, okay? You could take the x minus 2 square and then subtract from it what's underneath the root, which is 3. So this is x squared minus 4x plus 4 minus 3x squared minus 4x plus 1. And then I'm going to multiply that times x plus 4. So the x goes to all 3. I get x to the third minus 4x squared plus x. And then the 4 goes to all 3 plus 4x squared minus 16x plus 4. And then you're going to combine your like terms, and you're going to say f of x equals, again, this is multiple choice, so the f of x is there. Don't forget it. You need it. It's part of the function. And I'd get x to the third. There's 2x squared, so those cancel out. One's positive, one's negative. Then -15x plus 4, which is plus 4. That one. Questions on that one? Okay, 3 said if f of x equals 5 times square root of x plus 2 minus 3, find the inverse if no inverse exists, state so. So when would I say no inverse exists?
When the absolute value of the x.
X is an absolute value, or x is raised to an even power. Okay, remember it's the same thing as saying is it 1 to 1. So the question might say is the function 1 to 1? If it is, then find the inverse. If it's not, state so, or state why. Make sure you read instructions, because if you just say no inverse, which again some of you did in the quiz, if you just say no inverse, you don't explain why, you're losing the points. So be careful. All right, so this time it's fine. It is 1 to 1, so it has an inverse. I'm going to change the f of x to y. I'm going to switch the x and the y. I'm going to solve for that new y. So x plus 3 divide by 5. I got to square root both sides of the equation. So my numerator can stay as x plus 3 squared, but my denominator is 5 squared, which becomes 25. Then I need to subtract the 2. And then I substitute back in the f -1 of x. Again, if you forget it, you lose points, so don't do that. You can leave it like this. You don't need to find the least common denominator. I was going to say, I don't think the answer's there. It should have been this one. So it was missing the 2. Questions on that one? All right, 4 says f of x equals -x plus 3. Find the inverse of the function. If no inverse can be found, state so. What's wrong this time? Absolute value of x. So no inverse can be found because the function's not 1 to 1, specifically because the x is in absolute value. 5, divide the polynomial. So here's my long division, okay? I get 2x to the fourth minus 4x minus 1 divided by x to the second plus 2x plus 1. What's the initial what's missing from my dividend? I got an x to the fourth. Do I have an x to the third? Nope. Do I have an x to the second? Nope. So then it's first into first. This would be 2x to the second, which becomes 2x to the fourth, plus 4x to the third, plus 2x squared. You're going to change your signs. These cancel. Negative 4x to the third minus 2x squared. Bring down the negative 4. This is negative 4x. So negative 4x to the third minus 8x squared minus 4x. Change your signs. These cancel. This is 6x squared. This cancels. So 0x. Bring down the negative 1. Plus 6. And I get 6x squared plus 12x plus 6. Change your signs. This cancels. And that's my remainder. So remember that we said that if there's a negative on the leading coefficient, the negative has to go in between. So this becomes 2x squared minus 4x plus 6. Now, if I take a negative from here, does it affect the 7? If I take a negative out, is it coming off of both of those terms? Yeah, so this becomes minus 12x plus 7 over x squared plus 2x plus 1. So the negative comes off of both, okay? If the leading coefficient is positive, it's just a plus in between. But if the leading coefficient is negative, then the minus goes in between and it changes the signs of both of what's there. So that's 2x minus 4 plus 6 minus x plus 7, which is this one. And then the last one on here was said use synthetic division to find the remainder theorem to find f negative 3, given that f of x is 3x to the third plus 4x squared plus 4. So what goes on the outside? Negative 3. Remember, if it's inside the parentheses, you keep it. Only if it's after the x, you change the sign. There's an x to the third. There's an x to the second. There is no x to the first, which means I need the 0. And then the 4. Bring down the 3, multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column. And my remainder is negative 41. Questions on anything on the quizzes? Or yesterday we talked about, obviously, the graphing, those big graphing questions.